today we'll be doing Codeforces round 766 and let's go. Not shading. There's a grid with n rows and m columns, n rows and m columns. Some cells are colored black and the rest of the cells are colored white. In one operation, you can select some black cell and do the exactly one. Color all the cell in its row black and all cell in its column black. You're given two integers r and c. Find the minimum number of operations required to make the cell in row r and column c black. Or determine that it is impossible. Okay. Now that's an interesting question. Never seen that before in a div 2a. Okay, so test cases and NMRC basically. NMRC and NRC. So RC is what we have to find. That if we can convert it to black, and N and M are the rows and columns. N lines follow exactly M characters, black and white. Okay, so it's going to be probably a 2D vector. So basically a vector of vectors, 2D array. Basically, this should be initialized by what? Should it be initialized by? It should be initialized by n int. This should be initialized by m, and all should be black, I guess, or white. Everyone should be white, and then we take in and we take in the input. A of I comma j, and shouldn't this be character array then? And yep, this looks fine to me. And for each test case, if it is impossible to make this output -1. Okay, so let's copy the test cases and check our test cases on that. So what we can do at first is, so basically 0. So 0 would mean that the block is already colored. So basically if A of R comma C is equals already black, then what do we do? In this case, we just have to print out that this is 0 and just enter. Else, if it is not, then what do we do? Now what we can do is, if basically we can traverse the row and the column of the R and C, right? So we need to copy these loops. So first of all, not these loops but single loops, right? So what we'll check is if let's take a flag that is false, and if A of I comma C, basically I'm checking for every column, and we're having column C, no, every row in column C, if this is equal to black, that means we can do it in one operation. So basically flag will be turned true and we will break, and yep, and here also we will also check for basically for this should be wait a second, yeah, so this should be M and this should be R and this should be I, and if this is true then just break. And now we can check if flag is true then cout less than 1, else now what to do. Now if it's not true then it takes more than one try, right? More than one try. So let's take a test case where the answer is -1. So this can be done one, this can be done one, and so this is -1. So if there are no black, maybe else, okay. So let's just take it else if here, and if count of black, let's take a variable and count of black, basically initialize it to 0, and if a of ij is equals black, then just count black plus plus. If count black equals 0, then for sure we cannot do this. We'll see out -1 and end the program, right? Yeah. So what I'm thinking is that maybe we can do it in 2 moves at max. Like let's say you went, because in one go you can color any row, right? So if you can get color every row, then you can in the next step reach that R comma C. This is my hypothesis. This might be wrong, so I'll have to check it. So we got some errors. What is this? Never seen this. Okay, this should be char. And we can just copy this and keep it ready to submit. Okay, so there is a typo somewhere. 17, line 17. Okay, of course, flag was not declared. Okay, so this should be declared bool flag, and I'll just submit it. What is this? Compilation time exceeded. That's a new thing. Runtime error on pretest one. Let's see what's my runtime error in the new tab. Okay, so maybe some kind of error in this vector. No worries, we can change it to now that's an issue. The problem is that this should not be this, and string of a of basically m, right? problem is how will we know the length? Character A. Let's see if this works. This might be the reason for the runtime error. I don't even know. .codingblogs.com. Oh, so this ran successfully. Let's submit this. Oh, we did not check if our answer was correct. Oh, our answer was wrong. So in the first test case, they can do it in one iteration, which is weird. RNC. So basically RNC is 1 comma 4. Okay, so the indexing is starting from 1. So what we have to change is basically decrease R minus minus and C minus minus. Will that do? Let's find out. Okay, 1 0 minus 1 2 2 0 minus 1. Yeah, so that does work. Let's just reload it. Submit code. Problem number A, and we go. Here we go. So nice problem. Not setting. Rahul and Tina are looking forward to starting their new year at college. Nice. As they enter the new classroom, they observe the seats of the students are arranged in an N cross M grid. Again, the seat in the row R and C is denoted by the distance between two seats and CD is this. So basically A minus C mod and B minus B. I don't know if it's called Manhattan distance or some side or something else. I don't know. Okay, as the class president, Tina has access to exactly K buckets of pink paint. The following process occurs. Tina chooses exactly K seats in the classroom to paint with. One bucket of paint can paint exactly one seat. After Tina has painted K seats, Rahul chooses where he sits. He will not choose a seat that has been painted pink due to his hatred of pink. After Rahul has chosen the seat, Tina chooses a seat for himself. She can choose any of the seats painted or not, other than the one chosen by Rahul, obviously. Rahul wants to choose a seat such that he sits as close to Tina as possible. However, Tina wants to sit as far away from Rahul as possible due to some complicated relationship history. Now, Rahul wonders for k equals to this. If Tina has k buckets of paint, how close can Rahul sit to Tina? If both Rahul and Tina are aware of each other's intentions, they'll both choose seats as strategically as possible. Please help Rahul satisfy curiosity. Okay. So, int t cnt while t minus minus. Taking in the test cases, two integers int n comma m, the rows and columns. So why do they give this information? I never got to know. Maybe storing something or something. I don't know. So basically we can actually store the sum of n into m. I don't know why they give this information. For each test case, output n cross m integers. The distance between what? Rahul and Tina, if both of them chose the seats optimally. And for every k from 0 to n into m minus 1. What? Okay, one possible sequence of choices for the first test case for Tina is k is equal to 3 buckets of space as well. Tina paints the seats. Okay, so if what is the 1 1? What is the 1 1? Okay, so 1 into 2 minus 1, basically 2 test case 0 and 1. Okay, so in 4 and 3, so basically they start with 0 painted and 1 painted, 2 painted, and 3 painted. So in 3 painted, Tina paints this with pink paint. Rahul chooses the seat 3 comma 1, after which why does he choose 3 comma 1? That's the question. Okay, so 3 comma 1, 1 is the row and third is the column. That is weird because this should be the opposite, but okay. Okay, so obviously this is 3 and this is 1, so Rahul is here. Of course, it is not wrong. And Tina sits at 1 comma 3. Therefore, the distance between Rahul and Tina is 3 minus 1. Okay, 3 minus 1 and 1 minus 3. Weird. We can prove that this is indeed the minimum possible distance. Maybe other choice of seats which lead to the same answer as well. For k equals to 0, Rahul can decide to set 2 comma 2 and Tina can decide to set at this. So yeah, so pretty much it. So we just have to find central location after seeing this test case, but I'm not sure. Central location where Rahul can sit. So how are they painting it? That also determines it, right? He cannot sit on the pink seats. That's a weird question. Let's draw the space, maybe. Whiteboard. Come on, work. And we're gonna draw 4 cross 3 board, of course, and we'll draw the test case of 1 seat, right? So let's draw it. Oh, why is this happening? Can I draw straight lines? Okay, maybe not. Some way. This has to be a square, rectangle, this, right? So now we have to see, is there a color option? Is there a color option? There is no color option. Okay, so let's just remove this. So we can see that if she colors this, okay, what am I doing? Let's just take a pen, and if she colors the middle part, so she's also playing optimally, right? So she will color those parts that that reduce the distance and will not let him sit on those places, right? So let's see what she changes over here. So basically it has 0 1 2 3 4 5 6 and 7. So going from 7 to 8, something changes. Let's see what changes. So let's color this, let's color this, let's color this, and So basically the distance becomes 5 and 8. So this was done until this. And what will she color next? I think she might color this and this and this and this. So this is 7, right? And already you can see that. Okay, so now I know she'll color all of these boxes. So now he can only sit at either this or this and she can reduce. Okay, I got the hinge of it, but like in the previous case that this is not optimal because he can sit here. No, this is optimal, right? Because if he sits here, then she can sit here and the distance would be 1 2 1 2 3 4. No, not this 4. Basically this is 1 and okay, so wrong color. So basically this is 1 2 3 and 4. So 4 minus 1 is 3, and the row she can have is uh, the exactly opposite row, and which means this would be 3 minus 1, that is 2. Wait, but that would be 5, wouldn't it be? Okay, so he can reduce the distance by sitting here, and that would result in a distance of 4. Yeah, so that is pretty much the test case for 7. And then you can see that uh, if she fills this one, then yeah, if she fills this one exactly. Wait, why did she fill this one though? Then she can reduce the distance, increase the distance, right? So what I'm observing is the middle parts are getting filled first, but when the middle parts are not filled completely, what do we determine? Where should we put the paint? Plus, maybe it does not matter. Secondly, how do we find the optimal position of the Rahul? And next, how do we find the optimal position of Tina? Now, there are a lot of problems in this, so let's go step by step. So, let's say erase, erase this, erase this, erase this. So, if I consider the fact that in the next iteration this will be colored, I'm not entirely sure why this would be colored. So it changes on 0, 1 and 2. So something changes on here as well, right? So 0 was, he was sitting here and she might have been sitting here, right? And then in 1 paint she would have colored this, then he would have sitting here, and obviously she would have sitting here. So now both of these would be colored. Now he would be forced to sit here or yeah, here. I get the hints, but it's really a difficult question to come up with an algorithm to do this. Like finding the exact position where he will sit and she will sit. Maybe we don't need those algorithms where they will sit and we can just do it without it, without knowing their exact positions. My OCD has started to kick in. This just makes it worse. Okay. How do we deal with such a problem? So these were the center squares. And why would she color here and not at this positions? These. Why? Why would she do that? There are a lot of questions and I don't seem to have the answer to them for some reason. That's a tough question. Let's see how many people have solved this. If people have solved this, then I'll feel dumb. That's what I want to check. So not assigning. So every question starts with a not. That's cool. Who has written this round? I want to meet him. So one person has solved F. Probably rainbow, I guess. Let's see the submissions for this. Can we see the submissions? No, we can't. Maybe we can, maybe we can't. So maybe we could have yeah, okay, so it didn't want to open that. Let's just go and see how many people have solved this. Rain girl. Now the rain boy has turned to be a rain girl. Actually, that guy's name is Rain. Actual name is Rain. I don't know about this girl though. Okay, let's see. Okay, so let's try and solve this first. What the heck? Huh. So for any column, if we can fill these two rows, this, does it make any difference? No, it does not. Yeah, so maybe we have to first fill this column fully and then we go on with the other stuff, right? Maybe I'm right, maybe I'm not. And we are not focusing on a general solution. Like we'll need to maybe, yeah, this is what's starting. And maybe what will we do if the rows are odd? What will be the scenario then? Let's try and draw that. Let's take a 3 cross 3. Now 3 cross 3 is really short, so maybe 5 cross 5, and I don't have time to draw 5 cross 5. Brilliant. Wait, 1 2 3 4 5. And what was that? N into m minus 1. Why are there n into m minus 1 choices? So basically, yeah, so n into m is the total number of seats and n into m is the total number of seats and basically leaving 1 for the, what does this mean? like n to n minus 1, then where will they both sit, right? Where will they both sit? If it's n to n minus 1, like let's try. Let's see 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11 pieces filled. 11 pieces filled and the distance is 5. How is the distance 5 when Tina cannot even sit? Like literally. Like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So all of these are painted. Oh, okay. Tina can sit on a pink chair. Now that makes this question a lot more interesting. And I had completely forgotten that. F in the chat. Now what do we do? So Tina can actually sit at yellow. That's really weird. So for the last location, it's always gonna be the the n minus 1 plus, I'm unable to write on this, plus m minus 1, right? Because she can set at 0 0 and he can only set at one place. And then we should, yeah, I'm approaching this in the opposite way. Then we start removing stuff, right? Then we start removing stuff. Now, which location should we remove? That's a good question. We should remove this square, and this square. So we should remove the corners first, right? So the corners first. So basically the last one and the second last, third last, and fourth last. So the fourth, second last, third last, and last, second last, third last, and fourth last. So last four values will always be the same, right? Now what do we remove? Now if we remove any square of the, should we remove the squares of the larger side or the smaller side? The question is that. So let's say if we remove this square, right? We remove this square, then he will set at this location, and now you can set at this location. Tina can set at, basically, and now you have a distance of 1, 1, 2, and 3. So basically one of these is gonna reduce, and what effect will it have on, let's say if we had done this, wouldn't it be same like 5 minus 1, and in this case you would have sat here, so no difference, right? Because in this case, the rows, the distance by rows is staying same, and in this case the distance by column is staying the same. It is, right? So basically this one is reducing the, no, this one is reducing the column also, and not the rows too, and this one is reducing row and not column. row is getting 3, column is same. Now let's see. Now let's make sure that when she has lesser number of k, less k, which one will she choose? She will choose to color the columns that are less, right? So these she will color, right? Instead of these three she would need to color, so obviously she will go for these first and then these will come, right? So now we have kind of an algorithm. Yeah, so now what do I do? Now we just have to find the values. It's pretty difficult to write it as code, to be honest, and I've not figured out like if she doesn't let's say this would have been oh wait, this is actually a 5 cross 4 and not a 5 cross 5, right? Not 5 cross 4, it's 4 cross 5. You get the point, right? You get the point. So basically she goes and fills the lesser uh, lesser values first. How would we represent that in code, right? So let's do the coding. So see, so the max distance would be equals to n minus 1 plus m minus 1, that is equals to, let's just display this distance, max distance n del, let's make sure that this is 5 and 1 for both of the test cases. Yeah, so this is correct. And now we're gonna do is basically, now this is 5, so yeah, and this is 4, right? So first we'll find out which one is greater. um, so what if n and m are same? Then it does not require. So what if n and m are same? Now that's a good question. Okay, so I don't want to write code that is not generalized, but still I'm unable to think of non-generalized code. So int k is equals to max of n comma m, and if k is equals n, so basically, so n was the greater one from the both of these, then so let's take it to be minimum of n comma m. So n was minimum, that means we'll be reducing twice of n, right? So first of all, we'll go first take an vector which will store our answer, and let's initialize it with n into m minus 1 elements, and initialize with 0. And so for first 4, for it I could be less than 4 I plus plus, this might be wrong, and for the last 4 cases it will be same. So this should be minimum of 4 comma whatever the maximum value of the k is, right? And wait a second, we are going backwards, right? So we should probably take int size equals to n into m minus 1 and take it size minus 1 up till greater than equals to 0, or maybe size and basically and we missed the semicolon here, and let's take a count variable equals 0 so that we just count should be less than 4 and yeah, so count plus plus here and assign the value of answer of I to be equal to the max distance, and after that what we do is max distance minus minus. Yep, that's what we do. Now for the last the lower element, and take the twice of the, what do we call it, so we removed one from here, one from here, so minus 2 maybe. So for n minus 2 values, next values, right? So we copy this code. We are gonna require this code a lot. We should make a function ideally, but I'm not writing clean code right here, and I'm just trying to write working code. And so this time the CT value should not increase by n minus 2, and yep, so this should be correct. And after we have done that, no, we'll actually remove the maximum one, right? Maximum one first. So where is the maximum? Selecting of maximum, bro. Okay, so this is maximum. So first we'll remove this part, and then we'll remove this part, then we'll remove this part, then we'll remove this part, then we'll remove this. Should this make a difference? Wait, let me think for this one. Like these elements remaining colored, does that make a difference, like if this is removed or not? Like all of these are already colored, right? So now the question is, in these 6 boxes, obviously we should remove the corner ones first, right? Corner ones first, but seeing the test cases, this looks like all of these are 4s. That means, what does that mean? Should we always remove by 4? I'm shitting myself right now. Should we always remove by 4 or not? Like in this case, obviously if we remove this, then he's gonna sit here and reduce our column cost, right? Because she can only sit here and here also. So that will be he will be minimizing the distance. That's a tough question. I'm unable to guess that one. And when after we have done these 4, what what should we remove now? Should we remove this or this? If we remove this, let's say if we remove this, and now he can sit here, and he will have the same, right? So we can remove these four. Then it will be remaining with these, and then we can remove these four, maybe, or I don't know, man. What is this happening? So first, fourth. So we'll remove 1, 2, 3, 4, 5. 1, 2. Basically 4 from these, and 4 from these, and yeah. But this is 6, right? This is 6, changing at 6. That is weird. It's changing at 6. Let's see how many people have solved this. This might be out of our range. Okay, so 2000, that's a big number, but still not our range, right? So let's color this up. 1, 2, 3, 4, 5, 6, 7, 8, and obviously we did not color the last one for him to sit. And yep, so he can sit here and he can sit here. And now we reduce this. Okay, now we reduce this, so now he can sit here and you can sit here freely. And you can open this so you can sit here, and you can open this so you can sit here. And now the question arises, after this, how many things you should do? So 1, 2, 3, 4, 5, 6. Got it. Got it. Got it. Got it. Got it. So if if this part right here we can remove 4, that means this part is greater than or equal to 2, the remaining part, right? Then we can remove 4, and if we cannot, then we just remove 2, obviously. And after that we can just so this part will be no, I don't want to save this part, and this part will be reduced by 2, so these would be 2, and this should be 1 after this change. And all we can do is now what? Now this is basically 1, and this is basically 2, so we can do 2 more of the same number. Crazy stuff. Okay, so let's code this up. Let's take a number. So int rows remaining equals n, and int column remaining equals m. And after the first operations, we will be seeing that the remaining rows are reduced by, so the rows remaining should be minus equals 2, and column remaining should be minus equals 2, and yeah, So will not be counting maximum distance for I in, what is the vector answer for auto I in answer cout present I space answer until, let's try this. We forgot to remove the maximum distance. Vector was not declared. Call remaining minus equals to 2. I just want to see the vector after this. Okay, so blunder, big blunder. No, not a blunder. Not a blunder. Okay, so why is this guy having only one value? That's weird. Okay. So m is 2, right? So n into m is 2. 2 minus 1 is 1. Okay, so we'll have to add 1 here. Never thought I would do that, but yeah, that's it. And we had already allotted these numbers, so basically let's declare I outside this for our comfort. And so I minus 1 is just doing its job, and after it gets out of this, so basically I plus plus after every out, and we just remove this. Let's try with this. And we have to make this to be equal to less than 4, because we can either remove 4 or we can remove 2. What? Why does this not work? The approach and the code is simple, but now I don't know how to write this. Can anyone help me? So this is like the worst part right now, what I'm doing. And let's just remove all of this shit and start fresh. Now what do I mean by starting fresh? So let's just keep this amount of code and run our code, so at least this works. And we forgot this. Yep. Now what I'm thinking is there will be a while loop, and this should be true, and after every iteration we'll just decrease max distance by 1, and what we'll take care of is, now the length of columns and row have reduced by 1, and now they'll reduce by whatever amount. So if n is greater than or equal to m, n is greater than m, then if first of all we check, what do we check? If if n is greater than 2. Why is the compilation time getting fucked up? Why is that happening? Wait a sec. I haven't even put this loop. Like, this is literally, yeah. Now it starts to work, of course. And CT is less than 4. So this should go from 0, 1, 0, 1, 2, 3, 4. So this should be 4. What is this shit? So this should be I minus minus. My bad, my bad. So how is this 5, 5 coming, dude? If this is not like, oh, okay. This should be size maybe. Then, of course, because they are incorporating a 0. Am I doing everything wrong right now? Uh-huh. 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 Yeah, this should run. Why is this not running? Okay, maybe this ID is just shit. Yeah, that's it. I'm just changing my ID. No, I'm not. There's a lot less time left. So if n is greater than equals to 2, then we know we can reduce n minus equals to 2 and assign all of the values, the 4 values, the next 4 values with the same. The next 4 values with the same, right? So for int ct equals 0, I'm using this loop again. Let's make it a bit more legible, and let's do I++ here and use this here. Okay, so why does the indentation get fucked up always? We don't need this code. And 3 CT is less than 4, so basically we can reduce it by 4. So the next 4 iterations, and we assign it to the maximum distance, right? And so maximum distances has been reduced after this, of course. And again we check if let's take quick check. Do we even need this condition? Do we even need this? Now we check else if n is equals 1. So basically n is 1. Now we cannot reduce it by 2. So we will reduce it by fucking. So while n is greater than 0 and n is greater than 0, we'll do this shit. Else if so n minus minus and seat is 0 and we reduce 2 of the elements. This should be maximum distance, and yep, there you go. Now we reduce, no, we don't reduce max distance still, and now we're gonna do this same shit for our other brother, that is m. Should have made a function, guys, right? Because we could just pass m answer and that's it, that good shit. And yeah, we can do this and this m minus minus count to 0 and all good, right? And after every iteration we'll have to I++ because why not? So now that this all has been done, we'll now reduce max distance by 1, and yeah, that's pretty much it. Should do the job. So 1 2 3 4. How many? Okay, so this is overriding for some reason. Oh, now why is that happening? Should I plus plus not be present? That's a different story altogether, guys. Now I'm not sure why I plus plus should not be present, because literally uh, uh, should I plus plus not be present? Now that's the question. Let's see. So this is wrong. How do I fix this? 3 6, and then there should be 3. Mm-hmm, 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 mm-hmm. So 0, if I is equals to 0, I is equals to -1, then just break out of this loop. Still wrong. I is less than equals to 11. So the max distance is not becoming 3 at all for some reason. Why is this not happening, guys? So okay, I get it. So when these two are removing, so n should be reduced by 4 and not 2, and this should be removed by 2, and this should be removed by 4, and this should be removed by 2. Let's go. Still wrong. Like, what do I do to fix this? Like, no, guys. So if we are removing 4, so it's still getting reduced by 2, right? I think it was correct. Let's see this. Okay, so greater than equals to 0. Hmm. Why is this giving this to everything? So if it is greater than equals to 2, basically the size left. So in this case, maybe this is wrong. Okay, 3 or 6. So basically, now what did I do correctly previous time? So even if we are reducing one from above and one from down, it is decreasing by 1, 2. Then this does not make sense. So this makes sense to reduce by 1. And what does not make sense is, so 1, when we are reducing by 1, we are taking 2 and we are taking 4. Yep, let's go. Please, please work. Come on. No output. Now that's something I've seen first time. Like, no output. I just don't want to show you anything. Bro, I just changed just -1. Why is there not an output? Wait a second. That's a mystery. Should we include the I++? Still have. Why do we not have any output, guys? Now that's something really weird. Oh wait, what did I do? Compilation time exceeded. Maybe the while loop is never getting out of that shit, and basically greater than 0 should be the correct way. So 3, 4. So this is wrong pretty much, and I cannot even blame anything for this. Like, maybe this was correct. Let's see if 4 5s come now. So they do come. And so why is this not getting updated with 3? And I'm unable to figure out why I++ is not working. Literally, this should work, right? So let's see what is happening at this location. Both painting and choosing seats, obviously. Okay, so 3 comma 3. So am I decreasing max distance anywhere? No, I'm not. I'm just decreasing max distance right here. Here, right? So let's print out how many times this loop is running. Yes. And then figure out what has to be done. Hopefully this is going once. And this is breaking. Why is that? Let's see this. Is it breaking because of this? No, it's not breaking because of this. That means I is still in the range. So it is breaking because of this. N is greater than. Okay, so maybe this should be the ideal decision. What? So let's go back to the whiteboard. So basically what we did till now is that in 4 cross 3, basically this was 5 distance, 1 2 3 4. I don't have to show it again, of course, and go to the eraser. Now we remove this, 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 and this, right? And now we have 2 remaining of this and 1 remaining of this, and we just remove 2. Oh, I get it, 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 I get it. So while this 2 was remaining, so we removed these 2, right? And it also counted for this part, that there is remaining 1, so it removed 1 from here and 1 from here, and we cut 4 from this. Instead we should have just cut 2. Okay, so now that's an issue. Okay, so our code is wrong basically, and what we need to figure out is that we can reduce 4 or not. That we need to figure out. So how do we tell if we can reduce 4 or not? Basically, if the other column is greater than equals to 2 and your column is also greater than equals to 2, then we can remove 4, and we are actually reducing both of the columns while doing so. And um, yeah, so if n is greater than equals to 2 and m is also greater than equals to 2, only then can we can remove 4, and we are removing it from both of the columns, right? We are removing it from the both of the columns, or both of the dimensions. How could I forget this? So yeah, so this is done like at this point, and let's say if n is greater than equals to 2, but uh, what do we do then? Okay, so I don't know what to do now. I guess we'll just remove this. We wrote so much code just for it to go in vain. Else, if n is greater than equals to 2 and n is less than 2, then what do we do is if it's like 0, there is no point, right? Wait a minute, yeah, so no, bro, we are going in the wrong direction. Now we remove these 4, we remove these 4. So what remains is a single 2 cross 3 box, 2 cross 3 box. which one to remove. We'll remove this one, this one, this one, and this one. Now we'll have one this and so basically one here and two here. Will it always be the case that this is the way it will be left? Like if we start with an odd number, decreasing 2 will always lead us to 1, right? And if we start with an even number, then decreasing 2 will always lead us to 0 at the perfect step. And so what we have to look out is the greater number or the lesser number. If it goes down to 0, okay, so if let's say int mini is equals to minimum of n comma m, right? And let's go above, and so if n is equals to minimum, so that means the minimum was n, then we check if basically we do not even need to check this thing. If minimum percentage 2 is equals 0, then this drama will end with this, right? So wait, am I writing on the wrong code? Didn't I fix this greater than equals to shit? I fixed it, right? And what do we do is then we know it, right? And if it is a 1, then let's take bool odd flag equals false, and if it is odd, that means odd flag equals to true. That means this case would be executed, and basically this would be an else, right? So if let's say else if n is greater than equals to 2 or m is greater than equals to 2 but the other one is 1, so basically in this case we remove the whichever is remaining, that is if okay, so let's just make two else cases, if n is greater than equal to 2 and else if m is greater than equals to 2. And in this case what we'll do is we'll turn and odd flag is true, so ct equals 0. And for how much we will do that? For whatever is remaining, n is remaining, right? So I minus minus, e plus plus, and I plus plus at the end. Sweet setup, and we turn n to be 0 because we are using everything right now. And literally for this also we'll do the same shit, and let's write if m is greater than equals to 2, and we have the odd flag, and basically I'll just have to remove this and make this m, and yeah, this should work now. Let's see how much time is left for submitting. M minus equals to 243. Okay, there is a lot of time. So I thought there is only 5 or 6 minutes left. Okay, so what is this error? 35. Invalid operation. Okay, so mini. Right? Mini was the variable. Mini percentage to zero. And n minus 2. This is 43. Line 43. And here you go. What? A wrong answer. This is what I worked this hard for. Are you kidding me right now? No, this is really disheartening. I did all of this for nothing. Like, why is this happening? Like, how can this even happen? What? I don't even know, man, now what to do. I'm just gonna draw some shit now. I literally, I'm depressed. So, okay. Let's create another row. See? Right. Like, what is wrong in this code? Literally nothing. Oh, okay. I got it. No, I did not get it. So basically, this means that m is 1 and n is still there, and this means m is still there and n is 1. Let's take the case of 3, 4, right? 4, 3. That's the same thing. So 4, 3. So in this case, we know that we printed 4 5s and then it went inside this loop, and since after this, oh wait, is this correct? Like 1 2 3 4, so yeah, both of these are getting reduced by 2, and so this becomes 2 and this becomes 1, right? So yeah, okay, wait a second, I did this should be above this, of course, and well, that should not make a difference, to be honest, and yeah, that should not make a difference. So this is 2 and this is 1, so Okay, so this is 2 and this is 1. So basically we had one odd factor, that is 3, and that has resulted in 1. So here this should go inside this loop where, oh sorry, this should go inside this loop where n is greater than or equals to 2, that is 2, and this is odd, so this should be initialized to 0 and n should be okay, my bad. I'm such an idiot. Why did I even start competitive? Fuck, bro. Still wrong. Guys, this right here is overwhelming. I don't know what to say, man. I don't know what to say. Like, this is literally really bad. Okay, so 4 cross 3, 8. Wait a second. We did something bad. That means if I'm starting out with 4 cross 3, what I'm left with after removing 4 is 1 3 basically 2 cross 3 board and 1 basically 4 cross 1 board. This is what I'm remaining with. Obviously intersecting. So should I not do this? No difference. What? Previously I ran that and it worked, and this time it doesn't work. Like, what's happening, guys? What is happening? Code running once, then not running on the second time. Running on the second time. Does it self correct itself? Okay, compilation time. One, two, three, 4, 5, and 6. Mm-hmm. Maybe now I'm thinking the previous code was required. So we actually took these two, these 4, and added it to our this, and did not take care of these 2. So we'll have to refactor our code entire fuckingly. Lol. So not hurting anyone. But you already saw that this was wrong, right? What is happening? Expected primary expression before. Uh-huh. 4, 5, 6, and there is an extra. Now, why is there an extra? And why is there 0? I know in search of my love. I know. Mhm. Hmm. Hmm. So what I was earlier considering to be a rectangle, but it's not a rectangle. It's like a piece of a puzzle, right? It has this and it has this. So the this strip has a 4 cross 1 and this strip has a 2 cross 3. So these two are different. So what I'm trying to say is that the when we remove 4, what we are doing is, so there are two strips. One is basically let's say strip 1 n1, right? This should be equal to n, and basically similarly for every strip. So strip 2, strip 2 and m1 m, basically n and m, strip 1 and m, and this is m, and this is n, and this is m earlier. And what happens is strip 2's, so basically if we consider this as strip 1, so strip 1 gets reduced columns, so strip 2's column gets not column, rows basically, and this gets a minus equals 2, and strip 1's column gets a minus equals to 2 by stripping this. Oh wait, not stripping this, but stripping this. So his column gets reduced by 2. Yeah, so that's it. So basically, now there is a strip in between and there is a strip here, and we have to do this if S1N, S1M, and an S or S2M and an S2M. Obviously, if one of these is so we don't have a lot of time to solve this. I just give up. This was the worst question. Even after knowing the algorithm, I fucked up. Actually, these strips are not different strips, and these are same because if one person reduces, then the other person also reduces by something. But it's better to visualize it this way. And now we'll have to write these functions all again. And so we gonna write basically let's remove the last twos and make a copy of these just in case if we mess up. So if S2M is greater than equals to 2, then S2M will be reduced. So strip 2, what was strip 2? Strip 2 was this. And if his column is greater than equals to 2, then we reduce it by 2 and reduce the, what do we reduce of the strip? So now maybe we need to check which one is greater, which strip is greater. If S2M is greater than, basically if S2M is so if S2M is greater than S1M, then so we are not trying to remove here. What are we doing? S2M is greater than equals to 2 and S1M is greater than equals to 2. Then we go for this. What we did right here. What we did basically right here. instead of this. Now if this is filled and if so basically there are not, this should be for 8, right? This CT should go on for 8 in my opinion. Am I right or am I wrong? This should go till 8, and if one is greater than 2 and other is actually just 1, then so if wouldn't it be fine? Okay, Rahul chooses seat 3, 1. So the distance between Tina and Rahul is 3 minus 1. 3 minus 1 and 1 minus 3. Basically this and this distance. So isn't this same after every strip added here? So when 0 strips were added, this was this location. 4 strip was added. Second strip was added. Yeah, so basically if this is greater than or equals to 2 and this is 1, these are 1. What am I doing in my life? minus is equals to 6 and minus is equals to 6. At least the code runs on this. Okay, a lot of error. Okay, a lot of errors. What? The code vanished. How did the code vanish? Okay, so I need to change the while statement. Of course, I'll change that. Time limit exceeded. First of all, who wrote this shit? Mm-hmm. Mm-hmm. Why? Why is the time limit exceeded? Mm-hmm. Mm-hmm.